Hello, so in this video we are going to go over different methods of factoring. So remember that we are looking for different structures within the expressions that we're trying to factor. We're looking for the different patterns, and what we'll do is we will go through the different kinds of structures that we can find and then the steps that we would need to take in order to factor those kinds of structures. So the first method we are going to look at is factoring with GCF, and GCF stands for greatest common factor. So if we look at this first problem, 2pq squared plus 8p squared minus 6qp, what we want to do is look for what do we see here as a pattern. I see the numbers 2, 8, and 6, and what do those numbers have in common? They all have a 2 in common, so I can go ahead and I know I'm going to be able to factor out a 2. Now let's look at the variables. I see the variable p. There's a p here, a p there, and a p there. So all of these terms have a p in common, so I know that I can factor out a p. I also see the variable q, and I have 1 here and 1 there, but since I don't have it in all of the terms, then it's not a common factor. So I'm not going to be able to factor it out. It's going to be left in the factor. So the only thing they have in common is the 2 and the p. So what I'm left with in the first term when I factor out 2p is a q squared. And then when I factor out a 2p from 8p squared, that's going to give me 4p. And lastly, minus 6qp. So since this is a positive 2 in the front, then we are going to be left with a negative 3q. And we can go ahead and close the parentheses. From here, we want to double check and see what is left in the parentheses, because maybe there's a pattern here or some kind of structure that we can factor further. But upon looking at it, I see there's a square term, but it doesn't follow the quadratic form, so there's nothing else in common, so we're going to call this one factored. The next strategy we're going to look at is factoring quadratics. So we have the quadratic form, which is au squared plus bu plus c. And so this u can be, anything can be plugged into it really. So if we look at this example here, 24x squared minus 4x minus 8, this is in the quadratic form. Instead of u, we just have an x. So in order to factor quadratics in this form, we will break it down into our 2 parentheses. And then, actually, before I even do that, let's start with the greatest common factor, because I'm looking at this and I see the numbers 24, 4, and 8. And so all of those have a 4 in common. So I'm going to factor out a 4 just because I know that's going to make factoring a lot easier. So one tip here, and this goes for any strategy, is always start out by looking for the GCF, the greatest common factor, and factor that out. So that first kind of problem that we saw, always start with that. And then you can go in and try to apply different strategies from there. So I've factored out the 4, and now this is a quadratic 6x squared minus x minus 2 that I can break down. So to factor the quadratics, we break it down into our 2 parentheses. We'll start in the front, 6x squared. So I need to think of 2 numbers that multiply to give me 6. So we can try 3 and 2, and then x breaks down to x and x. And then we need to think of 2 numbers that multiply to give us negative 2. So for example, 2 and 1, because 2 is a prime number. So from here, I will go ahead and place those in the back. Now to figure out if these values will work and to figure out if we need a positive or negative, we're going to do the little rainbow method that I like to do. We'll multiply the outside numbers, so 3x times 1 is 3x. Multiply the inside, 2 times 2x is 4x. And then we think, is there any way that we can add or subtract 3x and 4x to get negative x, which is what we have in the middle here? And we would be able to do so if 3 is positive and 4 is negative, because then 3 minus 4 gives us negative 1. So I'm going to have to put a positive here, because this positive 1 times a positive 3 is what gives us a positive 3x. And I'm going to have to put a negative here, because negative 2 times 2x is what gives me this negative 4x here that I need. So now we have completed our factoring. And don't forget, you have that 4 in the front. So that was the greatest common factor. It's still a factor of this whole thing. So the whole thing together is factored. Next, we're going to take a look at how to factor by grouping. So what is the pattern that we're looking for when we decide if we are going to factor by grouping? Well, the pattern is you need to have 4 terms. So if we look at this example here, we've got 1, 2, 3, 4 terms. So that checks out. And the reason we need 4 terms is because we are going to break it into 2 parts. So once we break it into 2 parts, we're going to look at the first 2, in this case 3mn plus 4m, and we want to see what is the greatest common factor. So remember I said that's usually the first one that we want to take a look at. So I see that there's an m in common, so I'm going to factor out an m, and that leaves me with 3n plus 4. And over on the parentheses to the side here, I need to think of what do negative 9n and negative 12 have in common. So I know that they have a negative 3 in common. So I'm going to factor that out, and that leaves me with 3n plus 4. Now, what we're looking for when we are factoring by grouping is for these terms in parentheses to be the same. So in this case, 3n plus 4 is the same on both sides. That's what we want, because essentially what we are doing next is we are factoring out the greatest common factor. So in this case, they have a 3n plus 4 in common. So I'm going to bring that out in front here. And then what am I left in each piece when I remove the 3n plus 4? I'm left with an m and a minus 3. So this is going to be multiplied to m minus 3. And now that is completely factored. For our next example, we're going to look at factoring using the difference of squares. So in order to do this, we will follow the pattern a squared minus b squared is equal to a plus b times a minus b, or a plus b times a minus b. Oops, that's a typo. It should be a minus b times a plus b. So basically the order can switch. So what we're doing here is we need to see if we have squares, first of all, right? We have a minus, so that means we have the difference. Now we have to see if they're both squares. So I know that 9 is the same thing as 3 squared. And is already, we can see squared. And 4, I know, is 2 squared. So every single term in this problem is a square. So that means I have the difference of squares. And what I will do, I will put those together in parentheses. So this tells me that the 3x in this case is the a, and the 2 is my b. So from here, all I need to do is follow the pattern. A plus b, so 3x plus 2 times a minus b, 3x minus 2. And now this is factored completely. Now with squares, we can't do this with a sum. However, with cubes, we can do sum and difference. So this is the pattern that you want to follow for the sum. And actually for both sum and difference, you can always remember this first sign is always is always the same. So we have the same sign. And then this second sign here, this is always going to be opposite. This is just in case you want to really make sure you have this memorized, which you should, because you never know when it's going to come up. And then the last sign, it should always be positive. So we've got same, opposite, and positive. And now we're going to take a look at an example here. We've got 27x cubed plus 64. So I need to think, is 27 a cube? Well, 27 is actually 3 cubed, so it is. And we've got x cubed, and 64 is going to be 4 cubed. So these are all cubes. I'm going to put the ones where we have 2 cubes together in parentheses, just like that. And now we're going to follow the pattern. So we'll start with a plus b. So my a in this case is 3x, and my b is 4. So 3x plus 4. And then the pattern says I need to have a squared. So my a is 3x, so I'm going to square that whole thing. And then next comes minus ab. So my a is 3x, and b is 4. And then I'm going to add b squared. So my b was 4. I'll just square that. And it may look pretty long. All we have to do next is simplify where we can. So the 3x plus 4 will stay 3x plus 4. 3x squared, I can square the 3 and keep that x squared. Minus 3x times 4, that will give us minus 12x. And 4 squared is 16. So now that we've factored using the sum of cubes, what we'll do is we'll look to see if 9x squared minus 12x plus 16 can be factored any further. This is a quadratic. However, if you were to try to break this down and try all the different values for this, you'll see that it's not factorable any further. And so we will, didn't mean to erase that, we will call this completely factored. All right, so for this next and last method of factoring, it's actually going to go hand in hand with the problem that we just saw before, because we came across a quadratic that we couldn't factor any further using our 2 parentheses method. So whenever we get stuck, what I like to say is sing a little song. So we have the quadratic formula, and hopefully we all know the quadratic formula sum. X equals opposite of b plus or minus square root of b squared minus 4ac all over 2a. So you just sing a song, and then you've got your quadratic all factored. we've got x squared minus 4x plus 15. If you were to try to factor this, you will see that it won't work out. You've got x and x, and 15 would be 5 times 3, or 1 times 15, and neither of those will give you -4. So this method doesn't work out. We're going to jump straight to the quadratic formula. So this, in some ways, sometimes a little bit easier, because all you have to do is plug in and simplify. We just need to identify what is our A, B, and C. So from here, I can see that my A is 1, my B is -4, and my C is 15. So I plug it into the formula, and that's going to give me x equals opposite of b. So I said my b is -4, so I'm going to put a +4 plus or minus the square root of b squared minus 4a, ac, and my c is 15, all over 2a. Oops, my a is 1. There we go. So this is going to give us the factors. And if you're unsure of what we mean by factors, so if you were to have, let's say, for example, factored x minus 3 and x plus 4, then your factors are these values right here. So, which in this case would be x is equal to 3 and -4. So it's whatever you get once you actually solve the factors and set them equal to 0. So that's what we're going to be finding with the quadratic formula once we simplify it. So in here, we're going to simplify. -4 squared is 16, and -4 times 15 is going to be -60. It's all square rooted, divided by 2. And then we're going to do -16 minus 60, and that is going to be plus or minus square root of -54. Square rooted divided by 2. At this point, we have a negative number under the root. So we know we're not going to be able to solve this with real numbers, at least. We can solve this with imaginary numbers. We're not going to get that far in this at this point. We will definitely cover that soon. So for now, we're going to leave it at this: 4 plus or minus root -54 over 2. And this is really two solutions, because you've got the positive version and you've got the negative version. So I'll break it down over here. We have 4 plus root -54 divided by 2, and we've got 4 minus root -54 over 2. Those would be our two solutions in this case. So that's it. Those are all the different methods of factoring. Once you see the different structures, hopefully you can more easily determine which steps come next and be able to just jump right into those steps. But it definitely takes practice, because the more you practice, the more those patterns are going to jump out at you and you'll know what to do next.